All right, so this is a Unit 7 quiz. All right, so this is the Unit 7 quiz. So it says, knowing that sine of theta is 3/7, we need to find all of the other trig ratios. So what we want to do is remember that sine is going to be the same as opposite over the hypotenuse. So what we want to do is draw a little triangle. I'll draw a little triangle we had from the notes. We'll put theta up here. So opposite would be 3, and then the hypotenuse over here would be 7. So what we need to do is we need to find the adjacent side. So to get the adjacent side, we got to use the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared. Now we don't know what this is. That's going to be our a. So x squared plus 3 squared equals 7 squared. So remember, we always have to equal the hypotenuse. So we're going to get x squared. 3 squared is 9. And then 7 squared is 49. So what we could do is subtract 9 from both sides. So it gives us x squared equals 40. And we can square root both sides. So x equals the square root of 40. Now I don't need the negative one. We know that the distance has to be positive. But we do know that we can break down square root of 40. So square root of 40 can be broken down into square root of 4 and square root of 10. So this is 2 square root of 10. So that's what it has to be. So you can't do square root of 40. It's got to be 2 square root of 10. So we now can get all of our trig ratios here. So we start off with sine. So the nice thing is they gave us sine. So sine is 3/7. So if we flip it, we're going to get to cosecant. So we can do that. That's going to be 7/3. Oops, I want to make my 7 a green 7. So that's kind of nice that we can just flip those and be done with it. For cosine, so again, we're doing, SOHCAHTOA. So with cosine, we got to do adjacent over hypotenuse. So the adjacent side is the 2 square root 7. Sorry, 2 square root of 10. The hypotenuse is still 7, so we're going to divide by 7. So that's good. Remember, when the square root's on the top, you don't need to do anything. That's all set. However, when we do secant, if we flip it, 7/2 radical 10, that's not going to be the final answer because we have a radical on the bottom. So we need to fix this one. So when we did the reciprocal, it didn't work. So we need to multiply the square root of 10 is the problem. So we need to multiply both the top and the bottom by the square root of 10. 7 times square root of 10 is 7 root 10. 2 times square root of 10 times square root of 10 is 2 times 10, which is 7 square root of 10 over 20. So that's what our answer needs to be for secant. For tangent would be opposite over adjacent. So this is going to be 3 over 2 square root of 10. So again, this is going to be a problem. Before I tackle this, though, let's just flip this 2 square root of 10 over 3, because that's safe, because that's got a square root on top, so we don't need to do anything with that. So the one that we do need to fix is we need to fix the tangent one. So I actually want to move all this over. Give myself a little bit more space because my face is in the way. And we're going to do the same thing, though. We're going to, as soon as it works, there we go. We're going to go ahead and do 3 over 2 square root 10 times square root of 10 over square root of 10. So this is going to be 3 square root 10 on top, 2 times 10 on the bottom. So it'll be 3 square root of 10 over 20. There we go. And so that's what we're going to get for our final result. I can unbox that just because it doesn't look too good with the blue. That's a little bit better, so you can kind of see that. All right, so that's what we get for number 1. So not too bad. We had a lot of operations going on, but a lot of stuff that we did already. All right, number 2 then. For a 30, 60, 90 triangle with a hypotenuse of 8, and theta equals 30, find the ratios of sine theta and cosine theta. So we'll draw out our little triangle. We know theta is supposed to be 30 degrees. So we'll put that up there where we usually put theta. We got a hypotenuse of 8. And so that's going to mean this is going to be the adjacent side. And over here will be the opposite side. So thing is, doesn't really matter what all the numbers are. We do know that this is the 30. And for all of our answers, if we have sine of 30, when we do our sine, we would do opposite over adjacent, but every time that's just going to end up being 1/2. If we do cosine, every single time we know that's just going to be square root of 3 over 2. So that's it. That's all we're going to do. It's just a memorization one. That's all you got to do. All right, for number 3, if tangent of theta is equal to cotangent of 10, what is theta? So this is one of those rules where if we know that this one is cotangent of 10, that means it has to be tangent of 90 minus 10, which is 80. So we're going to get tangent of 80. And that's it. So we're all set there. It's just one of those cofunction rules. So the cofunction rule there is that if we're equal to the cotangent of something, that's equal to tangent of 90 minus something. So theta has to be 80. There we go. For 4, list the reciprocal identity for each trig function. So sine is 1 over cosecant. Secant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. And then cotangent is 1 over tangent. And that's all that one is. So it's just knowing those rules. It's just a definition question, just vocab on that one. For 5, angle has a reference angle with 52 degrees and the terminal side is in quadrant 4. What are possible positive and negative measures for the angle? So if we draw it out, we know our quadrants are going to go 1, 2, 3, 4. So if we have a reference angle of 52 degrees and we're in quadrant 4, that means what we want to do is make an angle where this, when we touch the horizontal, is 52 degrees. So that's our idea. So our negative one is actually pretty easy because we can just start at 0 and then go backwards. So we can cycle backwards to go just negative 52. So that one's pretty easy. However, if we want to go forwards, we'll notice that we'd be missing 52 degrees. Well, a whole circle is 360. So if we leave out 52, we had to go 308 degrees. So that's one choice for a positive. And so that's it. So again, it kind of deals with the whole circle. All the way around is 360. For number 6, this time we've got a terminal side in quadrant 3. So we get 1, 2, 3, 4. So now we're in quadrant 3. But we need to make a 30-degree angle with the x-axis. So the nice thing is, all right, we're just using the x-axis again. We need to have a 30-degree angle here. So again, we need to get a positive and a negative. So this time the positive might be a little bit easier because to get the positive, it's 180 for half the circle and then another 30. So 180 plus 30 is 210 degrees. For the negative one, again, we could count if we want. We could go back 90. And then if this is 30, that means that this has to be 60. So 90 plus 60 is 150 degrees. And we're all set. You could also do the 360 minus 210 to get to what was left over. Your choice. Both ways work out. Just put a little degree sign there. For number 7, which of the following are possible measures for the angle shown? Select all that apply. All right, so we just have to check all of them out. So we do know that this is 90. So if we go this way, we'll have 90. This would have to be 30. So we know that that's 120. So I'm going to look for 120. I found 120, so I can pick that one. Now, once I get to 120, I know that to get back there, I'd have to go all the way around the circle. So that's 480. So if there's any positives that are less than 480, I can get rid of them. So these two can't be right because the next time I would hit that, I'd be at 480. All right, well, if I'm going backwards, again, I got to go back this way. So that's 180. And then 60. So 180 plus 60 is 240. So negative 240 does work out. Then I have to realize, all right, if I want, I could go around again. So if I go around again, that's negative 240 and another 360. That would be at 600. So my next choice would be negative 600. Since this one happens before negative 600, can't be that choice either. So there's two answers on this one, so both B and E. Kind of like the others. We pick one positive and one negative in this case. For number 8, convert to degrees. So we want to say that if I've got pi over 4 radians, what we want to do is multiply by 180 degrees over pi radians. So it's kind of like a stoichiometry problem. Pi radians and pi radians cancel out. So we just need to do 180 divided by 4. So that'd be 90 and then 45. For the second one, we do the same thing. So 7 pi over 6 radians, and then 180 degrees over pi radians. Since that's our conversion factor. Pi radians and pi radians cancel out. 180 divided by 60 is 30. 30 times 7 is 210 degrees. And that's it. We're all set. Converted them to degrees. So it's that 180 over pi factor. Now we have to give some exact values. We have to find sine of 7 pi over 4. So now is where things are starting to get a little bit trickier. So we got to find out where 7 pi over 4 even is. So if I count by pi over 4s, we're going to have these ones in here because this is pi over 4, 2 pi over 4, 3 pi over 4. We know that's pi, so that's 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4. So this is where I want to be at. I want to be at this line. All right, well, when I'm at that line, remember sine is going to be the y. So if we go down, we're going to be negative because we're going down for sine. And we're going to get square root of 2 over 2. That's just what we got because, again, these both have to be the same. So we'll end up with square root of 2 over 2. For cosine, same idea, except this time instead of going down, we need to go across. This time we're going to be positive. So we're going to get positive square root of 2 over 2. So that's just where we're at on the unit circle. Not really much else to say there other than it's a memorization one. For the next one then, we've got tangent of negative 5 pi over 6. So this is where we need to split up into the sixths. So this is every 30 degrees is all the sixths. But we're doing radians, so we want to count in terms of 6. So negative 5 pi over 6 would be 1, 2, 3, 4, 5. So we're right here. So this is the place that we're at. So again, if we want to find out what tangent is, we can see that we've made a 30-degree triangle. So tangent is going to be our sine over our cosine. So we would end up with 1 over square root of 3. But we can't have that. So we can multiply both sides by square root of 3 over square root of 3. And we get square root of 3 over 3. So now the question is this going to be a positive or a negative? There's two ways to think about it. First way to think about it is to just realize that if I were to actually draw this line, that's super giant. But if I were to draw that line, let me make it a little bit nicer. Oops. That line has a positive slope. So since it has a positive slope, I know my answer has to be positive. So I'm good to go with that. The other thing I could do is realize that I'm going backwards and down. So backwards and down would be two negatives. So sine would be negative, cosine would be negative, and they cancel each other out. And that's it. That's all we got for that one. So there's just some unit circle questions. So you just have to know the unit circle for those. 10, what is sine of theta if cosine theta is 4/5 and theta is in quadrant 4? So this deals with the idea that sine squared of theta plus cosine squared of theta equals 1. So if I call sine squared of theta x, so I'm saying that x is sine squared of theta. Cosine of theta is 4/5, so we'll do 4/5 squared equals 1. So x squared. I want to make this just a sine of theta. So x squared plus 16 over 25 equals 1. We can subtract 16 over 25 from both sides. X squared equals, this is 25 over 25, so 9/25. We could square root both sides. So x equals plus or minus 3 over 5. So our whole idea here is we need to find out, okay, well, which one do we want to pick? Do we want to pick the positive or the negative? I can only pick one of them. And so the key is we're in quadrant 4. So 1, 2, 3, 4. Since sine is like the y, we're somewhere down here, so we have to be negative. So negative 3/5. And that's what we got. So that's it. And then is 11 the last one? Yep. Yes, it is. So for number 11, for theta equals 300, give exact values for each of the 6 trig expressions. All right, well, if we draw it out, we know that this would be 330. We're going backwards 30. This would be 300. So this is the line that we care about. So this is kind of where we're at. All right, well, cosine seems like it's going to be the easiest one. So I'm going to start with cosine because cosine is the x. So in the x direction, that's the small part, so that's going to be 1/2. In the y direction, that's going to be the square root of 3. Oops. Square root of 3 for right now. Just square root of 3. And then tangent is going to be 2. Oh, 1. Get myself a little bit confused. All right, so just finish up the last one. So it says theta is 300 degrees. Give exact values for everything. So 300 degrees would be down here. So this would be 360, so 330, so then 300. So this is kind of what we're going for, is this line right here. So if we're on the unit circle, the nice thing is with this one, we know that's the short side because this is a little 30-degree angle again. So that's going to have a value of 1/2. So that's not the tangent at all. That's the cosine. The sine is the height. So if we go up here, we got a height. That's going to be the square root of 3 over 2. And then for tangent, so tangent, remember tangent's like the slope. So in this case, we're going to get a slope of sine divided by cosine. So that's going to be square root of 3. So then what we got to do is just figure out all the others. So secant's going to be nice because we can flip 2 over 1 to just be 2. So that's pretty quick. For cosecant, we flip it to 2 over square root of 3, but that's not going to work. So let's go ahead and simplify that a little bit better. So times root 3 over root 3. So 2 radical 3 over 3. And then for the last one, square root of 3, if we flip it, we would get 1 over square root of 3. So 1 over square root of 3. multiply both the top and the bottom by radical 3, and we get radical 3 over 3. And that's it. So we're all set. I forgot one last part on this. So last part, I forgot to check the signs. It's always important to get the signs right. So since we're down here, we have to remember that sine is negative because we're going down, and cosecant is also going to be negative because we're going down. These are both positive because we're going to the right, but tangent and cotangent would both be negative. Again, we think of those as slopes. This is a negative slope, so that's sloping down. That's fun.